Okay, this is the part 2 of solving by graphing. In this section, we're going to be looking at how to estimate solutions. Okay, so estimating solutions occurs when the graph does not intersect the axis at an exact integer value. Okay, so we're going to start these problems the exact same way. So we're going to find the vertex. Vertex, remember, is negative b over 2a. So in this case, you got negative 6 over 2 times 2, which is negative 6 over 4, or negative 3 halves. Okay, so you got that there. Now, just like in the last section, you take that negative 3 halves, you substitute it in. So you've got 2 times negative 3 halves squared plus 6 times negative 3 halves minus 3. And we solve this the same way we did previously. So on the quadratic portion over here where it's being squared, you've got 3 halves squared, which is 9/4, times 2. Okay, here you put this over 1, you multiply that, and you end up with a negative 18 over 2, and then you have your minus 3 on the end. Now continually solving this, put this 2 over a 1, that gives you 18/4. We want a common denominator in this case, so I'm going to multiply both of those by 2. That gives me 36/4. And then the 3 is a common denominator. Remember, it's a 1 now, so it becomes 12/4. So adding this all together, so 18 plus, or minus 36 is a negative 18. Negative 18 minus 12 is a negative 30 over 4, or a negative 15 halves. Okay, so there's our vertex. Now for the y-intercept, that's, remember, 0c, so 0, negative 3, and we've got that information. So we come over to our graph. Negative 3 halves is negative 1.5, negative 15 halves is negative 7.5. So we go down 1, 2, 3, 4, 5, 6, 7 and a half, and it puts our vertex right down here at the bottom of our graph. Now for 0, negative 3, 0, negative 3 would be right here. The reflection of that would end up right there. Okay? Now, when you're working on these types of problems, it's a good idea to maybe do one more point, especially if it's an estimation. So we're going to maybe substitute in 1, because 1 is over on the right-hand side. So if I substitute in 1, I get 2 times 1 squared plus 6 times 1 minus 3. Now, this is a value that can be solved out relatively easily. So 1 squared is 1 times 2 is 2. 6 times 1 is 6 minus 3. So that gives me 4 minus 3 is 1. So remember, the number we substituted in was 1. The answer we got out was 1. So that gives you the point 1, 1, which is there. Okay. On the other side, because I can reflect this, this would give me the point negative 4, 1. And we now can graph using these points. So we end up with something like this and something like that. Okay, so using this estimation of a value, it crosses right there, which is not quite 1. This value right here, which is not quite negative 4, but they're close. So if I was going to estimate this, I'd say that this is maybe, looks to me to be about 0.75 or 3/4. Okay, over here, it looks like it could be just under 4. So maybe a 3.75 or 3 3/4, negative 3 3/4, okay, somewhere around there. And what you can end up doing is substituting in more values. Remember, we chose 1 here, so what if I substituted in maybe a half? Okay, if I took a half and substitute that in, we could see what we get. So if I go 2 times 1/2 squared plus 6 times 1/2 minus 3 equals, well, technically it equals y for this problem. Okay, so we substitute it in. 1/2 squared is 1/4. 2 times 1/4 is 2/4, or a half. 6 times a half is 3, so plus 3. Minus 3 equals y. If you solve this out, you get a half. So the number I substituted in as a half, the number I got out was a half. So it crosses the point at 1/2, 1/2, which is putting you right here. So you can see that that is even a little more there. So you can go through, substituting more values, And the more you substitute in, the more accurate your point would be. But for this problem, it looked like it crossed at about negative 3.75 and positive 0.75, and those are estimations. Okay? But the general idea is to get these things as close as you can, and you can substitute in more and more. Now, I'm going to show you in a few sections how to use your calculator to help this. But without a calculator, that's a pretty good estimation. Alright, pause the video, come back in just a few minutes after you try this next example, and see how you did. Alright, so hopefully you guys all had time to go through this. For this one, we would find our vertex. So you go negative b over 2a. Negative b would be 4. Okay, so 4 from there. 2 times a would be 2 times 1, which is 2. So 4 over 2 is 2. Now you take that and substitute it in. So you got 2 squared minus 4 times 2 plus 2. So you've got 4 minus 8 plus 2. That's going to give you a vertex of negative 2. Okay, so we go to our graph. We've got 2, negative 2. There's your vertex. Okay, your y-intercept. Y-intercept is 0c or 0, 2. So I go to my graph and put 0, 2 on there. Use the point of reflection to give you that. And just as always, remember it reflects around the axis of symmetry. So this distance here and this distance here have to be the exact same. Okay, so now that I've got all that information, I can draw in my parabola. So the parabola is going to come somewhere around here, go down, hit that point, come back up and hit there. And based on this graph, I've got that value and that value. Well, looking at how they set up on the graph, pretty good estimation is for this one, it's 1/2. For the second point right here, it looks like it's about, what, 3.5? And so I'm going to say my two solutions are x equals 1/2 and x equals 3.5 or 7/2, and there's my estimates. So those estimations need to be pretty close, and as we go through some of these assignments, you'll see for some you can get a little bit closer, but as always, you can graph and substitute in other values. So maybe in this case you substitute in a 1 and a 3 into my equation, see what I end up with there, and then you can just keep getting more accurate with your graph, which will then give you a more accurate solution. Okay, but like I said, in the future I will show you how to do this on your calculator to where you can get these exact answers. Alright, hopefully that helped. If you have any questions, please let me know. Contact me online, and good luck with your assignment.